Well, greetings, Mr. Kolazar's class. Today we're going to start out in Chem Video section 3.4, and we're going to look into the idea of the law of conservation of mass. Now in our notes, this is going to be objective 18. One of the things, remember, as we're going, want to keep all those distractions away, and then remember at any time, you can pause and rewind the videos, and then make sure that we're taking notes, and if you have any questions, take those questions down so that as we're working, you can look back and ask those in class the next day. So what we're going to look at is the law of conservation of mass states that matter is neither created nor destroyed during a chemical reaction. So we call that in science conserved, meaning that it's all kept. We're not going to lose or gain any matter during a chemical reaction. So the mass of the reactants, what we start with, is going to equal the mass of the products afterwards. And so we're going to start looking at our chemical equations and starting to get a couple ideas about them down also. So an example here is if we start out with 36 grams of water as a liquid, if you use electricity, you can actually separate water into hydrogen gas and oxygen gas. Now, during that process of separating out, you end up, if we started it with a certain amount of mass, 36 grams in this case, that in the end, if we collected all of our material, we'd have 4 grams of hydrogen and 32 grams of oxygen completely collected, or 36 grams to start with. After our chemical reaction has been completed, we'd have 4 plus 32. We'd have 36 grams of material afterwards. We can't gain or lose mass during a chemical reaction. So to look at a couple parts of this idea of starting out with the water on the left as a liquid, breaking it into the hydrogen oxygen gas on the right, which substances are reactants? The reactants are going to be on the left-hand side of the arrow. So our H2O, that's in the liquid state, is going to be our reactant. A lot of times we'll see the reactants are. So just to abbreviate, that will be anything on the left-hand side of our equation arrow. And that's going to signify that a chemical change, the beginning and the end products, are then going to be what we produce. The products are going to be on the right-hand side of the arrow. So think about the products, what is produced. In reactants, what reacts. They are found on, which substances are? We've got our H2, which is a gas, and we've got our O2, which is also a gas. And they are found on the right-hand side of the reaction. So beginning and end. And so as we look at our chemical reactions, one last practice problem for today. Let's say we had mercury 2 oxide. Mercury 2 oxide is a solid, and when it's heated, the mass decreases. Pure mercury remains, which is a nice silvery looking color container, and only has a mass now of 9.26 grams. So we've got our word equation, mercury 2 oxide. When it's heated, it's going to produce mercury and oxygen. Now, if we start out with 10 grams of mercury oxide, and we only have 9.226 grams left afterwards, what accounts for the loss? Well, we had some oxygen. Now, oxygen's a gas, so it would kind of leaving behind just that solid. So our oxygen is what's representing our lost mass there. And to find the lost mass of that material, if we start out with 10 grams of mercury oxide, and we have 9.26 grams of mercury left over, we'd have about 0.74 grams of oxygen that must be accounted for. So whatever we start with, we need to have the same amount of mass in the product side as we do the reactant side to keep everything equal or balanced, and that's our law of conservation of mass.